The passage of day and night is described in the Bhagavatam as a straight terminator rotating over a plane map, as we see here. Although this does not make sense in a literal plane, it is realistic in the planisphere model, and thus it adds weight to this model. Here we see the ecliptic and the zodiac projected stereographically onto the Earth map. The Sun and zodiac revolve clockwise together once per day, while the Sun moves counterclockwise around the zodiac once per year. Here the zodiac is projected stereographically onto Bhumandala. Note that as the Sun goes around the off-centered zodiac in its yearly orbit, it crosses the ring-shaped islands and oceans of Bhumandala. This ocean-crossing motion is described in the Puranas, and this also adds weight to the planisphere model. Bhumandala can be compared with an astronomical instrument called an astrolabe, which was popular in the Middle Ages. On the astrolabe, the off-centered circle represents the orbit of the Sun, the ecliptic. In an astrolabe, the Earth is represented in stereographic projection on a flat plate called the mater. The ecliptic circle and important stars are represented on another plate called the ret. Different planetary orbits could likewise be represented by different plates, and these would be seen projected onto the Earth plate when one looks down on the instrument. The Bhagavatam similarly presents the orbits of the Sun, the Moon, and important stars on a series of planes parallel to Bhumandala. The orbits of the planets are placed on additional parallel planes. Here we see the Bhagavatam's model of the orbits of the Sun, Moon, and 28 important star constellations. These lie in 3 planes parallel to Bhumandala. The layout is comparable to that of an astrolabe. Seen from the side, we find that the Moon is higher than the Sun, but this is simply an artifact of the astrolabe model. It should not be taken as physical. Seen from above, everything falls into place in projection in an astronomically realistic way. Although the Bhagavatam presents the Earth-Moon system indirectly as a planisphere model, the Indian astronomical texts called Jyotisha Shastras directly give a realistic picture of the Earth-Moon relationship. Here we compare the Earth, the Moon, and the lunar orbit in modern astronomy with their counterparts in the Surya Siddhanta, one of the main Jyotisha Shastras. Bhumandala as a map of the solar system. We have shown that Bhumandala and the orbits of the Sun, Moon, and planets have the structure of an astrolabe based on a stereographic projection of the Earth globe. But Bhumandala has another cluster of related features that identify it as a model of the solar system. Consider the plane of Bhumandala cutting across the sphere of the Brahmanda. Previously, we interpreted Bhumandala as a planisphere map, but now we shall take it as a literal plane. When we do this, it looks at first like a naive flat Earth, with the bowl of the sky above and the underworld below. But the Sun doesn't fit the naive flat Earth model. The Bhagavatam says that the Sun orbits on its one-wheeled chariot, which rides on Bhumandala. If we take Bhumandala as a literal plane, we see that the Sun orbits nearly in this plane. This is not what we expect in a naive flat Earth model. There we expect the Sun to rise above the flat Earth disk at a steep angle and then set at a similar angle. The motion of the Sun on its chariot corresponds to what happens in the Arctic during the summer, but it never would be observed at the latitudes of India. At these latitudes, the Sun orbits above an observer's head, as shown in this model. Since Bhumandala is close to the plane of the Sun's orbit, Bhumandala must stand at an angle to the plane of the observer's horizon. It is not the flat Earth imagined by naively extending that horizon. Rather, it can be argued that Bhumandala corresponds to the ecliptic plane. The Sun has two motions. In the planisphere model, the rapid daily clockwise motion takes the Sun around the cosmic axis of Meru relative to Bhumandala. The slow yearly counterclockwise motion takes the Sun around the ecliptic circle. Here the predominant motion is clockwise. The Bhagavatam talks about the Sun's clockwise motion, but it also talks about a yearly counterclockwise motion of the Sun relative to Bhumandala, as shown here. This motion supports the interpretation of Bhumandala as the ecliptic plane, since the Sun goes around the ecliptic counterclockwise once per year. The Bhagavatam explicitly recognizes this as a contradiction. It resolves the contradiction by describing the motion of ants on a spinning potter's wheel from different points of view, that of an observer standing beside the wheel and that of an observer standing on the wheel. This is the concept of relative motion, but we must realize that the Bhagavatam uses the same reference frame, namely Bhumandala, to describe different relative motions. The scholars Giorgio del Santillana and Hertha von Deckend carried out an intensive study of myths and traditions and concluded that the so-called flat Earth of ancient times originally represented the plane of the ecliptic and not the Earth on which we stand. In their model, shown here, the Sun also orbits around the plane of the ecliptic Earth. Later on, the original cosmic understanding of the Earth was apparently lost, and the Earth beneath our feet was taken literally as a flat plate. Here we see an early Greek version of this idea. In India, the Earth of the Puranas has often been taken as literally flat. However, the details given in the Bhagavatam indicate that its cosmology is much more sophisticated. It turns out that the disk of Bhumandala corresponds in some detail to the solar system. First of all, the solar system is nearly flat. The Sun, the Moon, and the 5 planets, Mercury through Saturn, all orbit nearly in the ecliptic plane. The Sun, Moon, and planets also orbit very close to one plane in the cosmology of the Bhagavatam. In one verse, the region where the planets orbit is compared to the thin space between 2 halves of a bean seed. The region of the planetary orbits is called antariksha, or inner space. In this picture, it is shown as a thin plate extending directly above Bhumandala. In the planisphere model, the planes of the planetary orbits correspond to the plates in an astrolabe. This is not realistic for a solar system model, but it is realistic to put the planetary orbits in a thin disk of space parallel to the ecliptic. The heights of the planetary orbits are given in a unit called the yojana, which is about 8 miles in length. All distances in the Bhagavatam are expressed in terms of this unit. The thickness of the antariksha disk is roughly the same as the spread of the orbits of Mercury through Saturn perpendicular to the ecliptic. In this picture, both this spread and the thickness of antariksha have been stretched by a factor of 3 for the purpose of easy comparison. In the planisphere model, we ignored the actual size of Bhumandala and compressed its ring-shaped features into a small set of rings around Jambudvip. But if we restore these rings to their real size, we find that they correspond to planetary orbits. First of all, we can understand the size of Bhumandala by comparing it with the orbit of Uranus. Measured in yojanas, Bhumandala is slightly bigger in diameter than the orbit of this planet. Within Bhumandala, a ring-shaped mountain called Loka is defined by the Bhagavatam as the outer limit of the luminaries. Perhaps coincidentally, this ring is about the size of the orbit of Saturn, the outermost of the planets visible to the naked eye.